Right, so let's have a look at example 17, which asks us to separate 1 over x minus 1 times x plus 1 into partial fraction, and hence show that the sum of 2 over r minus 1 times r plus 1 from r is equal to 2 to n is equal to 3n plus 2 times n minus 1 over 2n into n plus 1. So how are we going to start this? Let's do the partial fraction first. So we're asked to separate 1 over r minus 1 times r plus 1 into partial fractions. To do that, we have a over r minus 1 plus b over r plus 1. Multiplying the entire equation by the LCM, which is r minus 1 times r plus 1, we get 1 is equal to a into r plus 1 plus b times r minus 1. Then I'm going to say when r is equal to, let us say 1, we're going to get 1 is equal to 2a, and so a is equal to a half. Now, when r is equal to minus 1, we get 1 is equal to minus 2b, and so b is equal to minus a half. And so 1 over r minus 1 times r plus 1 would be equal to a half over r minus 1 plus minus a half over r plus 1. And of course, we can write this like, let us say, let's factor out the half. And we have 1 over r minus 1 minus 1 over r plus 1. All right, so we could write it like that. So in other words, the 1 over r minus 1 times r plus 1 could be written as a half times the difference of two terms. Now, what are we asked to do next? We're asked to show that the sum, and we're told hence from r is equal to 2 to n of 2 times r minus 1 here, r plus 1 is equal to something. But before that, let's just write this in a different form. This is the same from r is equal to 2 to n of 2 times 1 over 2, 1 over r minus 1, minus 1 over r plus 1. And of course, these 2's would cancel, and that this would be equal to 3n plus 2 into n minus 1 all over 2n into n plus 1. All right, so now the sum from r is equal to 2 of n of 1 over r minus 1 minus 1 over r plus 1. From r is equal to 2, we get 1 minus 1 over 2 plus 1, which is 3. That's the first term, plus the second term, which is when r is 3, we get 1 over 2 minus 1 over 4, plus the third term, which is when r is 4, we get 1 over 3 minus 1 over 5, plus we go now to when r is equal to n minus 1. We have 1 over n minus 1, which is n minus 2, minus 1 over n minus 1 plus 1, which is 1 over n, plus the last term, when r is n, we get 1 over n minus 1 minus 1 over n plus 1. So let us see which terms are going to disappear. So in other words, here we have minus a third and positive a third. So the negative term will find we'll find the positive version of it. Two terms or two values to the right. So we have minus 3, and then 1, 2, 3 values. Sorry, we have minus 1/3, and then 1, 2, 3 values to the right, we have a positive 1/3. So the positive values will find the negative of the value 3 terms to the left. So in other words, I'm guessing that minus a quarter will go, because there's a positive a quarter 3 terms to the right. Positive 1 over n minus 2 will go, because there is the negative version of it 3 terms to the left. Positive 1 over n minus 1 will go, because the negative of it is 3 terms to the left. And looking at everything, it looks like these are the terms that remain. These are the terms that remain. So what remains is 1 plus a half minus 1 over n minus 1 over n plus 1. And so this becomes 3 over 2, a half plus 1, minus 1 over n, minus 1 over n plus 1. Next, let's use the LCM, which is 2n into n plus 1. 2 into the LCM, we end up with 3n into n plus 1. N into the LCM, we end up with minus 2 into n plus 1. And n plus 1 into the LCM, we end up with minus 2n. Simplifying the numerator, so I'm only looking at the numerator now. We have 3n squared plus 3n minus 2n minus 2 minus 2n. We're going to end up with 3n squared. 3n minus 4n is minus n minus 2. I think we'll be able to factorize this. 3n here and here. 2 here, 1 here, minus and plus. So bringing the entire thing together, we get that the sum from r is equal to 2 to n of n over r minus 1 times r. Something is amiss. All right, this should be 2 over r minus 1 times r plus 1, which is equal to, as we have shown, the sum from R is equal to 2 of n of 1 over R minus 1 over R plus 1 is equal to the numerator 3n minus 2 over times n minus 1 all over the denominator, which is 2n into n plus 1. So let's see if there's anything more to the question. I don't think so. This is it. This is the question that we were asked to do. Nothing more to the question. All right, from the start of it, going down to the end of it. This is example 17. All right, so next, let's have a look at example 18. Example 18 says, given that 3r into r plus 1 is equal to r times r plus 1 times r plus 2, minus r minus 1 r times r plus 1. So we're told that that is equal to that. We are to show that the sum of r times r plus 1 from r is equal to 1 to n is equal to 1/3 n times n plus 1 n times n plus 2. All right, first of all, 3 times the sum from r is equal to 1 to n of r times r plus 1. 3 times that sum is equal to the summation from r is equal to 1 to n of r plus 1 and then r plus 2 minus r minus 1 r plus 1. 3 times this sum is equal to that. 3 times. So let's find 3 times this sum from r is equal to 1 to n of r plus 1. So when r is 1, we have our first term, which is 1 times 2 times 3 minus 0 times 1 times 2. That's the first term. Plus, when r is now 2, we have 2 times 3 times 4 minus 1 times 2 times 3. When r is 3, we have 3 times 4 times 5 minus 2 times 3 times 4 plus when r is n minus 1, we have n minus 1, n minus 1 plus 1, which is n, and then n minus 1 plus 2, which is n plus 1, plus the last term, when r is n, we have n into n plus 1, n plus 2 minus n minus 1, n plus 1. So let us see if we can identify the terms which are going to go. All right, so here's a repeat of those terms. So the positive term is going to find its negative 3 terms to the right. So the positive terms is going to find its negative 3 terms to the right. 1, 2, 3. So this goes. The positive term is going to find its negative 3 terms to the right. So this one is staying. That's staying because there's no term 3 terms to the right to get rid of it. No, sorry. This should be this. This should be negative. So you have to be so careful not to make any errors. So this should be negative. Okay. All right. Oh, look like I made an error. So I made an error, but we should be able to correct it. Be able to correct it quickly. N minus 1 minus. So this is the n minus 1 term. So we get the minus of it. This is n minus 2, n minus 1, n minus 1 plus 1, which is n. N minus 1, n minus 1, n minus 1 plus 1, which is n. Good, good. Plus now the last term, we have n into n plus 1, n plus 2 minus n minus 1, n, and then n minus 1 plus n minus 1. It's the n term, so it's n minus 1, n, and then n plus 1. This is the nth term. All right, so as I said, the positive term is going to find its negative 2 terms to the right. Positive term is going to find its negative 2 terms to the right. So this is going to go, because it's negative, it's 2 terms to the right. The positive term is going to find its negative 3 terms to the right. So this go, this go. All right, the negative term going to find its negative 3 terms to the left. So this negative term is going to go. All right, and this term is equal to 0. So what we have is that 3 from r is equal to 1 to n of r into r plus 1 is equal to n plus 1, n plus 2. And if I divide both sides by 3, I'm going to get that the summation from r is equal to 1 to n of r into r plus 1 is equal to 1/3 n plus 1 times n plus 2. So let's see if that's what we're asked to do. And yes, that's what we're asked to do. Example 18 is asking us to do exactly that. And that's what we did.